In this chapter, we're gonna fragment the skull and simulate it by using the RBD material workflow. So let's go. So I'm going to use the RBD material workflow, but before that I have done some example. So let's scroll past it and dive inside. So let's check the first example, and on the first one I would like to show you the convex decomposition and the VDB sphere. I mean, it is just a quick review, I think you know that, but we never know. So I just have a font there. Let's update the viewport. Okay, a poly extrude, a remesh, divide to have only triangles, a fuse, and an assemble to create the name attribute. So here is the RBD material fracture with an exploded view. So this is what we have, and I've just set a basic constraint, a glue constraint, with a value of -1. So here is the mesh, the constraint. Let's just update the viewport, okay, and the proxy. So if I import that into the simulation, this is what we have. So as you can imagine, it's not going to work properly. And this is because we are using the proxy by default. So we need to, inside the detail panel, to set the proxy geometry to convex decomposition. So now if I import it, it will be more accurate. But I've already activated this option, so if I take it off, this is our previous proxy collision geometry. So you need to activate that, sorry. So let's see the other example. This is almost the same thing, but here we do have, instead of convex decomposition, packed spheres. And this is the result. Let's refresh the viewport. So same thing, if we import it inside the simulation and I press play, this is going to work correctly. But again, you need to activate this option. Otherwise, you will not have the sphere. It's going to create the proxy around it. Actually, I use this option with the sphere quite a lot. I like it, it's very fast. It's less accurate, but I'm using it really often. So you have to choose which one you want to use. And for the skull simulation, we are going to use the convex decomposition to have a more accurate result. So let's check this example. So this is very basic, and just like a table with an assembler there. I'm creating some connection to connect all the elements and applying the RBD material fracture. So if I check the constraint there, it is not connected. In this case, you just have to go inside the RBD material fracture and check the update constraint and increase a bit the search radius. So let's say 0.1, and now it's connected. If I take it off like this, I will create just constraint per element, per piece, sorry. But I want to link them together. So let's import it there, and that's it. So let's see a final result, which is not really impressive. And on the third example, which is the constraint switch type. So it's just a box up like this. No. And if I take the constraint, I could take this off actually. But the interesting part is inside the constraint tab here, we do have the glue, but as well, we activated the switch to subconstraint when broken. So in order to make it work inside the DOP simulation, you need to have your glue constraint and your bullets of constraint. And it is going to create primitive attributes called next constraint name and next constraint type. So let's check the result. So this is the glue one, and this is the collider. And as you can see, when it breaks, it's just transforming and turning to soft body. Okay. And this is the result with the Voronoi. That's it. Good. I was showing you those examples because we are going to use all those things. So let's go. Oh, actually I forgot to show you there and inside the constraint type here. Okay, we can just instead of having the bullets of constraint, you can turn this off and turn this one on. So this is the spring constraint relationship. And if so let's check the name. This is spring, and if I set it directly to the RBD material fracture there, no, that's V. This is the result we will have. So you can do that kind of things as well. And that's it. So let's go back to the upper level. Okay, so let's create the RBD material fracture and set it on the upper scroll. So I'm just going to set the value that I liked, because I don't think it's really necessary to show you each step. So let's do it. So I want to call it upper score 1. I want 90 there, 150, and for the noise rec 888. On the second iteration, I want the upper score 2. I want 0.2 there and 1. I want 5 there, 1 here, and 10 for the frequency. I don't want any chipping. Detail, I want it. I want 0.015. I want those and this one. 0.15 for the noise 8. I want 0.03 there. Here I want 0.15. And for the frequency 10, 10, 10. I want to use the convex decomposition to 0.1, and I don't want to apply any constraint properties. So let's see. Okay, so let's see the viewport. Not you, up. Okay, and let's see the exploded view. Not you, view, like this. Okay, and this is what I have. Okay, so I am happy with that, and I would like to do the same thing for the mandible. So before that, let's create 3 new with out mesh, let's say, out constraint, okay, out proxy. So I want to check the first one, the last one, and the second one. So this is my constraint and the proxy. So it's okay. Let's do it for the other. RBD material fracture, and I want to connect to the mandible. So I want the concrete, I don't want the fracture purpose. I'm going to rename that mandible 1. So I want 25 there, and on the noise rec 12. 12 and 12. On the second iteration, I will just copy this one and call it 2. I want 0.4 for the fracture ratio, 10 points for the scatter seed, and 10 for the noise frequency, and the cutoff density to 0. I want as well not the chipping but the detail, up, up, and the 0.15, same thing. Here I want 0.15 for the noise 8, and here 0.03 with 0.1 for the noise amplitude and 10 for the noise frequency. I want as well the convex decomposition, but this time I will use 0.05, and I don't want the constraint properties. Okay, so let's check. So I want to apply the exploded view there, and this is what we have. So I'm okay with that. And let's see, so just the mesh, the constraint, like this, okay, and the proxy. Okay. So now we can do it on the last one, on the teeth. So RBD material fracture, if it works. RBD material fracture, okay. Up, I want to connect it, but here, because I have 28 names, so I want to fracture per piece and use the name attribute. So I need just one fracture level, so let's take one and keep this one. I want to name it teeth 1 with 4 points for the scatter points, 40 for the resolution, for the volume resolution, let's say 0, 0, 0 for the noise frequency, sorry, and 0 for the cutoff density. So let's go in the detail. Let's say the same thing for the other. And I want the convex decomposition to 0.03, like this. And I don't want to apply the constraint properties. So let's check in the viewport. Up there. Okay. So it's very basic, huh? But we don't need it's going to be enough for the TIFF. So let's plug it there, there, and there. So this is the mesh. Okay, the constraint and the proxy. And I'm fine with that. Okay, so now I just need to cumulate it like this. So I want to apply this on the first one. This will be the upper skull. Okay, this will be the mandible, and this will be the teeth. Actually, I'm going to copy to keep this one and teeth. And now I just need to copy those names. So here I just want to apply this RBD material factor to the group at name upper skull. Okay, same thing for the mandible and for the teeth. So let's connect those. I don't need those anymore, but I will keep it just in case, we never know. So now I want to cache it, and I will use the RBD pack. So down shift, we can do that, and my grid cache. Okay. Let's call it fragmented skull, like this. I want the color blue. I need as well to set it like this, PGO-SC. I need to make it only strict on the range, and to copy you, copy. Okay, and let's cache it. So it's done. Let's import RBD unpack, connect to the first input, and I want to connect those. Not you, the first one, the second one, and you. Okay, this will be a bit better. I need a timesheet for the my grid cache as well, as you know, and I will just copy the same expression. Okay, so let's see in the viewport what do I have there, and connect to, let's say, the RBD unpacked. Okay, let's see the exploded view. Okay. So now we can import that directly to the .NET. So .NET, I need an assemble to pack it, to pack the proxy. Create pack, I have already the name, so that's okay. And I just need to connect to the first one. So let's call it RBD sim, or maybe RBD skull sim. Not you. Okay, and dive inside. So I need an RBD packed object. I need the rigid body solver. I need the ground plane. I need a merge and a gravity as well. Good. So let's copy all of this. Not copy, but link. So this one. This one. Where is my ground plane? Okay, weird. And the ground plane. You and you. Okay. So I need the first input. And let's see the viewport. I need to check the guide geometry, and this is not what we want, so we need to check this one. Okay, and let's see if it works. Yes, it's good enough. So now we are going to add all the elements to have a nice simulation. So let's do it. So first of all, I would like to add the constraint network for the glue. So let's do it there, and constraint network here, like this. I need the glue constraint relationship as well. Up, I want to connect this there, and I need to set to the second input. So I have to connect the second input as well, just here. And let's see directly to the viewport. Okay, let's see if it works. I don't want to see this one. So it doesn't, because I don't have any properties here. So let's add one. So RBD material, not you. RBD constraint properties. Okay. No, I don't need you, you, and you. So I want something like 3000 there. And let's set it here as well and see if it works. It doesn't, because I have to change the name there. And I want to multiply the strand by 1. So let's see now what we have as a result. Okay, so the first thing, as we can see there, there is no connection between all the elements. So I want to add that. And let's go back here and a bit earlier here. So I would like to connect all the elements, sorry, with connect adjacent pieces. Okay, I want to set it adjacent piece from surface points, and this is what we have. So for example, if I connect this to the constraint geometry inputs, and I go there with a null at the end here, let's see what happens. Okay, so now all my elements, all my pieces are connected. But as you can see here as well, all the teeth are connected together, and I don't want that actually. I don't want those connections. So we are going to blast it. So let's go back there, and I want to blast all those connections. So in order to do that, I have to create an attribute. So let's add an attribute wrangler. And first let's add the name. So string, I need to iterate over the points. So string name equal, I want the name from the primitive. So 0 name and at premium, not you, like this. And now I want to add an attribute, let's say teeth, with a value of 1 for all the teeth. So I need to if start with, oh, I need an S there. So name and the string teeth. So this function is going to look into the name attribute, and if it starts with this string, then it returns 1. So I want to say if it starts with this name, this string, so equal 1, then at f at teeth equal 1. So now if we take a look to the geometry spreadsheet, we have a teeth attribute and 1 for all the teeth. Okay. So now I want to promote the teeth attribute to the primitive. So let's set it there, primitive, and average. This is important. So if we take a look to the geometry spreadsheet, to the primitive, actually I don't have anything, so why? If I go back to the connect adjacent, okay, it's because the connect adjacent just set the teeth attribute to 0, so I want to copy it from before. So let's use an attribute copy by name. So I have the name on the point there, and here on the primitive, so I just need another attribute promote. So to promote the prim, so the name attribute from the primitive to the point, like this, and I want to copy the teeth attribute by the name. Okay, so now it's consistent, and as you can see here, I have 0 on the mandible and 0 on the upper skull, and all the other is set to 1. So this is what I wanted, and if I promote the teeth attribute to the primitive, now I have 0, 0.5, 1, and that's it. So if it's 0, it means there is no connection with a tooth, sorry. And if it is 0.5, there is a connection between the upper skull or the mandible with a tooth. And if it's 1, it's a connection between teeth. So I don't need those. So I want to blast it. Blast. On the primitive, I want to blast the teeth with 1. And now, as you can see, I don't have any connection between those. I just want to add a group now over the primitive to say this is my initial connection. So init like this, and this is what I need. So I want to connect this one. And actually I forgot to set an offset here on the second fracture level on the upper skull, just here, and on the mandible as well, on the second, and just here. It is just because I want to match with the value that I like. So now let's cache it. Okay, so now let's check the constraint. And this is what I wanted. So let's make a flipbook of this. And actually I'm just going to add a transform pieces as well, like this with a time shift. This is temporary, but just to check the result with the res mesh. So this one, and the mesh. Okay, and let's see the result. Okay, so this is what we expected, and now I would like to add an initial velocity. So let's add it there, here. I want to add on the initial state tab the value that I liked. So it was 1, here it was -8, here 0, here 1000, here -450, and 500. I would like as well to decrease the strength of the glue constraint, but just for the teeth. So let's add an RBD constraint properties. And here I want to select just the teeth. And I'm going to copy this value, past relative reference, and I want to divide it by, let's say, 20. And maybe increase the production iterations to 3. So let's check the result. And this is what we have. Okay. So this is good, and I would like to adjust a couple of parameters. So let's go back there, and I want to set the density to 1800. This is overall the bone's density, and let's increase just a bit the rotational stiffness to 10.05. I want to as well to check the guide geometry, so let's take off this one, and I would like to decrease this. So now it's a bit better, and maybe multiply the shrink amount by 2. Okay, so I would like as well to add a couple of variations. So I'm going to add a RBD cluster. Just there. And the value that I liked was 0.75. I don't want this one, and the size 2. So let's see in the viewport if it works with the geometry color. So something like this. And maybe I would like to change the cluster to cluster strength. So let's add a new RBD constraint properties after the global one here. And I want to set it there. Oh, actually I have to set the RBD cluster to group constraint. And now I do have the cluster to cluster, this one. So let's do it, just there, cluster to cluster, and I want to set the strength to 1. Okay, so it's time to check it. Let's take off the geometry color. So now we have this, so this is okay. And oh, there is a crazy piece there, so I will fix that. And at some point I need to make it fall apart. So this is what we will do. So I just need to add there, let's say, a pop speed limit for the crazy piece there, and I want to limit the spin to 150, let's say. And I'm going to create an attribute directly to the constraint, so let's make it a bit lower and add an attribute handle not you, and let's call it on the primitive f at var for variation equal random at primnum, but I want to fit this one, fit 0, 1 from 0.45 to 0.9, like this. Okay, so now I'm just going to create a subsolver just here. And I'm just going to multiply the strength by this attribute over the frame. So I need an attribute wrangle there, and I just want to multiply the strength. So on the primitive, f at strength times equal f at var. So let's see the result. So this is what we have, and this is okay. But I would like actually to keep this area, so the skull, let's say the eyes and the nose area, not broken and longer. So let's do it and go there. And before that, maybe I would like to change the friction on the ground plane. So let's make it 0.5. And the good value for the sleeping was the angular threshold 0.1 and the sleeping time 0.2. So now let's select the area we want to keep longer. So let's do it just there with a group linked to this one, like this, and I would like to select, so let's see the viewport, not you, but the bounding sphere. So the value that I liked was 2, 1.5, 2, 0.1, 2.3, and 0.95. So now, as you can see, this area is selected, and let's call it, I don't know, cluster. So I would like to make those constraints stronger. So let's add an attribute wrangle. And let's say over the primitive f at strength equal, let's say chf. I want to make it manually. Strength. Okay, and I will just copy actually what we have on the global strength. So copy parameter and just there. Past relative reference, but I would like to increase by 10. And actually, maybe with some variations, so let's add a float var, like this, equal, I want a random over the at primnum, with a fit 0.1, like this, and let's say 0.5, 1.2, like this. Okay, so let's set back it there. And check the results. Okay, so for now I just have that one, but I think it's because I forgot to apply the multiply over the cluster. Yes, that's why, because now everything is multiplied by 10, so I don't want that. I just want to apply it over the cluster, this group. Okay, so let's go back and a bit like this, a bit more like this on the flipbook. Okay, so this is what we have now. And this is almost good, but I would like to have a better behavior, like pin constraint there, you know. So I'm going to try to use the soft body, the switch. So let's go. So I just want to go there and activate the switch. So I want the soft position and rotation. This is okay. And I just need to add inside the .NET a new like this, merge with the bullet soft constraint. Bullet soft constraint relationship like this. So let's set it 5 and disable the collision and with the name soft. So this is okay. And at some point I would like to break it. So let's go there. And I want to add an attribute wrangle. Let's say over the primitive, if, so let's say the distance is superior than 0.15, then remove the connection. 0 at primnum and 1. But I have to apply this operation just on the soft constraint, so let's split my constraint with the primitive and the name. Constraint name, and I want equal glue. So if it is equal to glue, I want to multiply the strength by the var, and if it's not, I want to break it by the distance. So let's merge everything. We will rename it later, and like this. So let's check it. So this is what we have, and as you can notice now it's way less explosive, but I don't like it actually. So I'm going to keep the soft body constraint, but only over this area. So let's do it by maybe as well adding, make it round, let's say -10, and here add an attribute wrangler and say over the primitive if at group cluster equals 0, then s at next constraint name equal nothing. So now let's check directly inside the viewport. So here is my glue, and let's set it, I don't know, maybe green for the soft. So let's play it. And as you can see, only this area have the soft constraint. And I guess this is what I want. So let's do a last play blast of a flipbook, sorry. Oh, I don't want you. So let's take it off there. Let's make it like this. And a new play blast, a new flipbook. So this is what we have now. And it's better. So it's almost what I want, but I need to change a couple of things to make it match with my results. So, and I need to go back on the RBD material factor. Let's set manual. I need to allow editing and go inside because I've changed the radius just there. So to 0.1. Same thing for this one. So here and here, but it was 0.2. And same thing for this one. And it was 0.1. Okay, so let's go back and recache. Okay, so let's check the number. I need to auto-update this. And it should be alright, so let's see directly the viewport. Okay, so this is the result. So this is fine for me, but it's not the exact same result that I have. And I was wondering why. And after some time, I just realized that I forgot to apply here the variation. So I just need to multiply it by the var and it should be good. So let's do another flipbook. So let's check it. This is our final result and it's good. So we just need to cache it now. So let's import it with .import .import like this. I just want to copy that. Okay, I want the same thing, so the fetch pack, and I'm just going to copy again this one for this one. Okay, I want the RBD. Is it RBD? Yes, it is. So let's delete those and make those one green. I'm just going to copy paste what we have there. So the matrix plus the position for transform pieces. So let's copy paste it here. Again, I want to take off this one and set a my grid market cloud cache like this. Let's call it RBD sim PTS, or actually RBD score like this and like this, and add a new one. So let's add it there, out, and I'm just going to copy paste the name like this. Like this. I need as well to set it load from disk BGO.sc, sorry. I want the global control for the frame range. And that's it, so let's cache it. Okay, and now we can make all of these a bit more organized.
you.